Hi everyone, my name is Niseth Kurdish and I'm majoring in materials engineering, and today I'll be speaking on an experiment that I conducted, a surface treatment that I conducted on a titanium alloy to be used as a bioimplant. This is the agenda that we will follow throughout our presentation, which will include the introduction. We will address two studies briefly, what they did, and follow that with the methodology that I used in this experiment, and last but not least, the summary and recommendation that we would leave. It would be a crime, and honestly, unapologetically, if I started this presentation without firstly addressing what titanium alloys are. Titanium alloys are a class of metal alloys that exhibit mechanical properties that are similar to those of the human bone, such as modulus of elasticity. Now, this property in particular makes the material the most suitable in between all the materials that have been used before, such as stainless steel and cobalt chromium, to be used in the biomedical and clinical applications. But since nothing lasts forever, and even if it does after some time, it begins to fail, the reasons to the implant failure of titanium alloys are related to the corrosion, the corrosive environment that they inserted in, the also integration, the strength, and the fatigue stresses caused by the cyclic internal stresses. Now, previous studies, these are two previous studies that were conducted before. On hydroxyapatite, I would just say HA, and the EDM, which is this electric discharge machining surface treatment that we use to enhance the corrosion resistance and the bioactivity. And the second study that was conducted was a graphene coating technique. Now, this is the experimental setup that is normally used when this is the electric discharge machining, and this is the hydroxyapatite mixed in a deionized water. This is the experiment that is used, and in this experiment in particular, the purpose was to enhance the corrosion resistance and bioactivity of the element. Now, as we can see in this first figure, the occurrence of craters and microcracks and nanohydroxyapatite deposition followed by the globule. This is because the EDM process, the electric discharge machining process, is related to the heat energy, and it creates this sort of like a deep hand, like a curve or something, like some sort of pit formation. And in this case, we don't see that as much. Here, the sample was submitted was coated with a bioceramic powder called HAM, followed by an electric discharge machining treatment. Here we can see that the occurrence of HA deposition is in certain specific areas, and the porosity is not as much related to this first image. So with that being said, the treatment that is most suitable to enhance the bioactivity of a titanium alloy is the coupling of the EDM with an hydroxyapatite bioceramic powder. Now, onto the graphene modified treatment. Now, this schematic is a brief representation of how the analysis was conducted by applying a surface treatment coating of graphene technique on a grade 5 titanium alloy to assess for the aptitude of the material in a biologic system. Now, this study in particular followed the path of quantitative casual comparative research design by collecting the data of graphene coatings that were prepared using a CVD technique, chemical vapor deposition. Now, on to the research question. Now, the research question here is, can we in fact enhance the mechanical properties of a titanium alloy to be used as a bioimplant if we couple the selective laser melting treatment with an ion implantation of calcium phosphate? Now, the method that I chose was the mixed research design, and I chose to stick by this method because I firstly intended to conduct an experiment, explain what happened in the experiment, and follow it with an evaluative research. And this experiment throughout took a total of 6 months to be conducted. Now, the surface treatment that I used was I had 3 samples firstly. The first sample was submitted to a laser treatment, and the second sample was submitted to a selective laser melting ion implantation coupled with ion implantation. And the third sample was submitted to an SLAM and plasma vapor deposition coating. Now, the results are that on the as-built sample, we can see that there was an external morphology of the biomaterial, which means that it promoted bone growth and osseointegration. Now, on the second specimen, what happened is that we could also see a good bone integration, a bone structure, and good osseointegration. But on the last sample, it exhibited it enhanced the fatigue performance and accompanied by the high levels of hardness of the element. With that being said, visual limitations that I found while conducting this experiment was that normally the ion implantation technique is used in the dental implants, which means that dental implants are different morphology in comparison to the human bone. And the occurrence of larger pores formation, which we have to further tackle on how to minimize the occurrence of large pores. And the recommendation that I would like to leave is that we can apply the selective laser melting followed by the calcium phosphate ion implantation treatment on a sample to be used in a bioimplant. Thank you.